So, hello again, Black-Scholes delta, how to derive that. Right, let's have a look at this today. It's simple calculus after all, but maybe still something interesting to learn. Let me write down the formula for you, which I'm sure you are dreaming of in the nights. So let's have a go at this. Black-Scholes formula. So we take the value of an option. That's for the value of an option. Say vanilla option. Okay, V is discounted spot. I take discounted with the foreign rate, N of D plus, minus strike discounted with the domestic rate, N of D minus. So that's the Black-Scholes formula, which I'm sure you know. So the auxiliary quantities D plus and D minus are, as usual, log of forward over strike plus or minus 1/2 L squared cap T over L square root T. F is the forward rate, so spot times e to the RD minus RF T. That's the forward rate. Right, the rest is clear, right? We've got N, cumulative normal, spot is S, what is K is strike, right? There's one more thing we can add in, which is the indicator variable phi. So I put a phi in here. Maybe there, and we've got phi is equal to +1 for a call and -1 for a put. Right. That's the Black-Scholes formula. I like to see it like this because it's going to work for calls and puts, and simultaneously you've got plus and minus in the D's. That you still see in some textbooks D1 and D2, maybe you've seen that before. I personally don't like it because then you don't know where the plus and where the minus goes, and all the symmetry goes based, right? So D plus and D minus is my preferred notation. Well, now what about the delta derivation? That's quite straightforward. If we take the derivative of dv with respect to s, right, that's delta. How do we do that? Right, so, well, we check where is s and take the derivative of that. Simple calculus. If you haven't done calculus in a while, let me help you with that. So it's actually, let's do a refresher from school, right? Calculus 101. If you got f of x and f prime of x, maybe that helps. So if you have 5x, then the derivative is 5, right? 5x plus 8, the derivative is still 5. X squared, some of you probably remember that, it would be 2x, right? It's funny that when you go to high school to school 12 years, and all that people remember is the derivative of x squared after 12 years. It's typically not much more than that. The good thing about calculus is this translates to other letters. So if you got v of s and v prime of s, you can do the same thing, right? So if you've got 5s, then the derivative is 5s plus 8. We'll still have a derivative of 5, and s squared will have a derivative of 2s. So we don't even need that. All we need is actually this, right? We take a look at what's the coefficient of s and then do copy paste. My standard sentences of half of our life, maybe more than that, is copy paste. If you know how to do this, then you're all set. So where is s? S is sitting right here. Well, bingo. Take the coefficient and you're done, right? So that should be phi discount factor foreign rate n of phi d plus, right? Ready to go. That's delta. As simple as that. Questions? There might be. Some people have done calculus in a little more detail and are more attentive than others, and so I've had people complain about this. Let me insert a page. The reason why some people complain about this is the following. That's because, let's take another color. So if you look carefully, then actually S is sitting here, and so it goes back into F. So F is sitting here, it goes back into D plus and minus, and therefore D plus and D minus actually, strictly speaking, contain S, and therefore why shouldn't we really do it properly, and why not use the chain rule, all that calculus that we know, chain rule. Well, you could, and the answer, I'll tell you a secret, the answer would still be the same. And I'll tell you another secret. When I first saw this in Hull's book back many, many years ago, then I thought it was wrong. It wasn't. So, and I figured out much later why it isn't wrong. The result is not incidental. I mean, if you do the calculus and you all the terms, all the algebra, they'll all cancel. So it is correct, but there's a reason behind that. Let me insert another page here and show you why it's actually correct. And that's got to do with homogeneity. Right? Homogeneity. So if we, what you need to imagine is that what if we measure all prices of the underlying in another unit, right? Instead of dollars, you go to cents, then everything will blow up by a factor of 100. But that's just taking another measuring tape. It's like converting miles to kilometers, pounds to kilograms, and all that. So there's nothing fundamentally changing here except that we're using another measuring tape. So if now we write the value function as a function of S and K, right, and compare that with the value function inflated by a factor alpha. So we got alpha S and alpha K. Think of alpha as 100 converting dollars to cents, then everything will be a factor 100 bigger. So the value of the option measured in cents will then also be a factor of 100 bigger, right? Does that make sense? So this is homogeneity, very simple for vanilla options, right? And these are the options we talk about. So this looks pretty straightforward. It's not really surprising, but it's very helpful, because now what you can do is you can take the derivative of this equation with respect to alpha and then set alpha equal to 1. And please keep that order, right? So otherwise it's quite boring. So if you differentiate with respect to alpha, you're going to get v of S and K. And so on the left-hand side, we get, well, now we do have to use the chain rule. So the inner derivative is going to be S times V and then Vs. And then the second term is K times Vk. Right, so that's the structure. Right, so the value function of a vanilla function always has this structure. That's just a homogeneity-based result. Spot times Vs. So and that one, remember, is delta. That Vk is, by the way, called dual delta. That'll pop up. It's not a market Greek, right? But it's a parameter Greek, very useful for constructing Wald surfaces, checking arbitrage. So keep that in mind. Right. So how does it compare to Black-Scholes, right? So V of S and K, what is that? It's spot discount factor ND plus. I'll do it for the call only, minus continue this. Minus k discount factor nd minus, and that's it. Right, so now all you need to do is compare coefficients. The coefficient of s is that guy here. So therefore, bs is in fact a discounted n of g plus. You can do the same thing for the put, it's the same result. So it just drops out of homogeneity, right? The good news is that this result here is generic. It's not dependent on the Black-Scholes model, that you realize that. If you don't need any model assumption, this is independent of all models, right? Independent of all models. This is what you get. The structure is always like that. The Black-Scholes model is one special example. And in that special example, you can just compare the coefficients and see what delta and dual delta are going to be. So whatever you derive with very naive calculus, forgetting the chain rule, this is once allowed, other than in high school. Forgetting the chain rule is the best thing to do, because it saves you a lot of headaches. And it actually is correct. Right. Good. I'll stop for now and let you digest this.